In number 28, we're trying to sketch a graph. Remember, sketch just means it needs to be roughly correct, doesn't need to be exactly correct. If this was a free response question, you'd be doing something that looks like this to determine the difference between here and here. But now that this is a multiple choice, these two graphs, while they might seem the same in terms of their sketch, they are slightly different depending on how you look at what's going on. So the first thing that I'm noticing is that my coefficient out in front is a positive, which means we are on the top half of the graph, and everything is in the top half of the graph. So that's not as helpful as it seems. If this was a negative, then it would be something that lives down in the bottom half of the graph. The next thing that I'm seeing is that I have a base of 2, which means I am getting bigger. This one's getting bigger, this one's getting bigger, and it's getting bigger. So it seems that they're all getting bigger. What else do we notice? Some key features that are super helpful. When x is equal to 0, anything to the power of 0 is 1, so that's just 1, and 3 times 1 is just 3, which is a fancy way of saying the y-intercept is going to be whatever that number is out in front of here, as long as this is just x. If it's like x plus 1, weird things happen. These are both just x, which means the y-intercept is 3, the y-intercept over here is going to be 5. So I'm looking for a y-intercept of 3. This one has a y-intercept of 2, which eliminates a. Down here we have a y-intercept of 2 again, so that eliminates b. C has a y-intercept of 4, which eliminates c. And D has a y-intercept that's in between 4 and 2, therefore it's 3. The correct answer in this one is D. In number 29, again, I'm looking for a y-intercept of 5. That's kind of that key giveaway on each of these. So the y-intercept down here is much less than 5, so it's not A. For B, y-intercept is down here at 2. We're looking for 5. It's not U. For C, the y-intercept does appear to be a 5, so let's say that's probably going to be the answer. And down here, we have a y-intercept of 4, which is not the answer. So we did get it correct with C. I didn't have to verify anything else, just as a way to remember this. As well, whenever I have a base underneath the exponent that is a number in between 0 and 1, I call these my small values. Small values mean we decrease. Moving on to number 30. We're looking for an explicit formula, and I'm noticing in all of these multiple choice, we always start with the first value. Remember, the n minus whatever number you have, this number is talking about what number is this. If this is a 1, that means this should be the first value. So is the first value negative 4? It's positive 4, which means that one's not right. This one says that the first value is negative 24. Well, now the second value is negative 24. If you change that to a 2, it would have been maybe okay. But not the case. It's saying that the first value is 4. That is indeed the case. And this is saying that the first value is negative 24, which is not the case. Other things that are helpful in these sequences are to remember how to change from the next term to the next term. If you're constantly adding, then this number or this sign should have been this operation, there we go, there's the right word. This operation should have been adding or subtracting because we were multiplying each step. That's why these are all multiplying. So we're multiplying by negative 6, which means our base should have been negative 6. These are not the correct base, so you could have eliminated A and D just based on the base. In number 31, let's go ahead and look at that base first because I'm curious what's going on. Again, I'm noticing that we're definitely going to be multiplying since our formulas have multiplication. So how to get from 3 to 15? Well, you multiply by just a positive 5. Which of these has a positive 5? Well, that's a negative 1/5. That is a negative 5. That's a negative 5. Just with a base, you can see that the answer is C, but you can also see that the first value is negative 3. The first value is negative 3. That also gives it away as well. In number 32, we're trying to find the recursive formula. Just as a way to remember this, when you have a sub 1, this is saying that the first value in the term. So the first value is 2. Well, the first value is negative 2, so that's not right. It's saying that the first value is 2, which is still not right. Okay, this one is saying the first value is negative 2. That's the only one that's right. And this one is saying that the first value is 2, which is not correct. So what is this stuff up here saying? So this is saying if you want to get the term that you're looking for, let's say I'm trying to get the 12th term. The term that I'm looking for in this case is the second term. Well, you take the second term minus 1, which is aka the previous value. So the way that I interpret this entire a sub n minus 1 is the previous value. So to find the value that I'm looking for, look at the previous value and multiply it by negative 6. And to get from negative 2 to 12, you do multiply by negative 6. So that also makes sense. In number 33, I want to look at the pattern first this time. I'm noticing that all of these are multiplication, so I should be multiplying by something. How do I multiply to get from 2 to negative 10? Well, I multiply by 5. Will that help us? Well, multiply by 5 is the only choice for B. I have multiply by negative 2, multiply by 2, multiply by negative 2. We want to be multiplying by 5. Also, take a look that the first value is -1, which is incorrect. We should be saying that the first value is -2. This one does say that the first value is -2, which is why B is the right answer. This is also saying that the right answer, that the first value is -2, which is similar, but the only problem here is it's multiplying by 2 each time. -2 times 2 would have been a -4, which is why C was eliminated. All right, moving on to number 34. So we're trying to find the 10th term here, and you can just write this pattern out over and over again. But the whole point is there should be a faster way. And I mean, you guys won't have calculators on your test, so you'll have to find some other way of doing this. Maybe this question does kind of rely on having a calculator. If you do have a calculator, I think I'm leaning more towards giving you guys a calculator on this one. You can just write them out, right? So you say that this is the first value, the second value, the third value, the fourth value. You just keep doing this over and over. You say, okay, well, the fifth value, I can see that the pattern is multiplied by 2, multiplied by 2, multiplied by 2. So just keep multiplying by 2. Fifth value is 16. You do the sixth value, multiply by 2 again, you get 32. You keep doing that over and over. You will eventually find that it's 1024. How? There's another way of doing these. Usually the way that we've done these in class is I change this number to like 20 or 30 or something that's really tedious to do over and over and over again. So I'm forcing you guys to use another strategy, like using a formula. The formula that you have up here, these explicit formulas, are really, really useful. And it's kind of set up these exact same ways where you say, hey, I'm going to say my a sub n is equal to any value that I want. I could have chosen 1, 2, 4, 8, whatever I want. I'm just going to randomly choose 1. So that's the first value. So I can say this is going to be times some number to the power of n minus 1. Again, I'm subtracting 1 because this is the first value. If I had instead chosen 4, then I would have been saying minus 3 because that's the third value. And then what am I multiplying to get to the next step? Well, I'm multiplying by 2. Therefore, the base down here is 2, and I have a fancy formula. So to find the 10th value, a sub 10, I'm replacing the n with a 10, which means this n is also going to be replaced with a 10. I can say this is 1 times to the power of 10 minus 1. And I realize now from looking at this that a is incorrect. I should erase that because this is going to be the same thing as, well, 1 times anything is itself. So I can kind of ignore the 1. This is going to be 2 to the power of 9. And 2 to the power of 9, I happen to have off the top of my head is 512. If you don't know that, you can just enter this into a calculator. Let me prove to you with a calculator using a scientific calculator. Let's put it on the left-hand side here. That if I do 2 to the power of 9, you get 512. You can also do that by hand by just doubling over and over and over again, but that's the same thing as it's just doing it over here. What about over here? I want to use the formula to show you how fast that this works. So I'm going to set up my formula. I'm going to say that a sub n is equal to, okay, I'm going to randomly choose that one. I'm going to say 6 times, okay, what am I multiplying by each time? Well, to get from 2 to 6, I'm multiplying by 3. So I'm going to say 3 is my base, and it's going to be n minus, okay, which term did I choose? Did I choose a first term? No, I chose a second term. So I'm going to write a 2 up here. And now I'm going to find the 10th term by saying, okay, swap out the n for a 10 down here. When I do that, I say this is 6 times 3 to the power of 10 minus 2, which is just 6 times 3 to the power of 8. So I'm just going to type on my calculator. What is 6 times 3 to the power of 8? And I get my answer. It's the one that has the first two digits as 3 and 9. The correct answer here is C. Moving on to another question. Oh yeah, so you definitely need a calculator on the test because you have these questions, don't you? Okay, so you'll have a calculator. How do you do these? These, again, are just found by doing a formula. So it's still that same type of geometric sequence where you say, okay, we know that it's going to be, y is going to be equal to a times b to the power of x. And let's go ahead and fill this in. I'm going to say that this is going to be equal to, well, I need some starting amount. So is there a starting amount? 4% is not an amount. 5 years is not an amount. This is a starting amount, and it's saying that the current balance, aka when we start off, we have $1,735. So I'm going to say A is 1735. I'm going to ignore the commas. And I'm going to multiply by however much it's going up. So if I just multiply by 4 here, that means it's multiplying the entire thing by 4. But 4% is 4 over 100. Literally, if you write out the words percent, it means over 100. So this is going to be 4 over 100. But the problem is, if I multiply by 4 over 100, this number will go down. And just to prove it to you really quickly, if I do 1735 times 4 over 100, you see that we went down to $69, which is bad because we should be having interest rate meaning we're going up. We should be going up from 1,735. We went down to 69.4, which means there's something wrong, and that's because we need to always multiply by 1 as our starting amount. If we multiply by 1, nothing happens. If you want to go up by 1, you do plus an amount, or if you want to go down from 1, you do minus amount. But every time that you're multiplying with an explicit formula for growth, decay, whatever it takes, whenever you're doing geometric problems, you're always starting with 1, because multiplying by 1 doesn't do anything. So I'm going to say, you're going to add those. This is my rate, and then I'm going to say the power of x or t or whatever variable I want up here. So I have my formula, and now it's saying, okay, plug in 5 into my formula. So I'm going to say 5 is being plugged in for x here, and I'm going to just type that all in. I'm going to say 1735 times, okay, then I'm going to start my parentheses. I'm going to start my parentheses, and I'm going to say 1 plus 4 over 100. That was supposed to be a 1 up here, wasn't it? And that's supposed to be 100 down here, and this is going to be to the power of 5 now. And tells me that I get 2,110.89, so that's going to be option B. And then for number 37, it's very similar, except notice that this word removed means it's going down, which means instead of having a plus sign in here, I'm going to have a minus sign. It should be going down from 1. So I need to find some starting amount. So this is an amount. 9 passes is going to be plugged in. 25% is going to help me find this fraction over here. So I'm going to say I'm going to start with 510. I'm going to multiply by 1 minus 25%, or 1 minus 25 over 100, and then I'm going to plug in 9 passes up here, because whenever I have a power, you're repeatedly multiplying by this, multiplying by this, multiplying by this, changing by 25%, changing by 25%, changing by 25%, and I can just type this into my calculator. Now I can say 510 times, in parentheses, 1 minus 25 over 100, and then this is going to be to the power of 9, and I get 38.3. 38.3 is going to be option A. For number 38, now we're getting into the properties of exponents. So for properties of exponents, just remember that whenever we have numbers out front, those get multiplied. Technically, every single one of these, this, there's 6 things that are being multiplied altogether. So you're kind of looking for like terms. I'm using like air quotes when I say that. 4 times 4 is 16. So I'm looking for a number of a 16 out in front, and we're done, because none of these have a 16 in them. But how do I know that it's u to the power 4 and v to the power 3? Well, everything is being multiplied. So whenever you have the same base, look at this u, look at this u, they're the same letter, you just add the powers whenever you multiply. So this is a power of 3, this is a hidden power of 1. If I add 3 and 1 together, you do get 4. And same thing for the v's. Whenever we're multiplying the v's, I'm going to add the powers. 4 plus a negative 1 is a positive 3. What about number 39? Again, I'm going to use that same trick. I'm looking at 3, multiplying them, and I get 9. Oh, look, 9, done and done. How do I know that I have x to the power of 4 and y to the power of 2? Again, everything is being multiplied. So this is x technically to the power of 1, y to the power of 1, y to the power of 1, and x to the power of 3. Therefore, I just add all the powers with the same bases. So x and x, there's a 1 and a 3 that add together for 4. For the y's and y's, I have a 1 and a 1. I add them together, and I get 2. All right, moving on to the next one. So now I have powers to powers. And remember that powers distribute. So this, this one you don't really need to distribute, because it doesn't matter whatever's on the inside. Anything to the power of 0 is just 1. It's one of those things that you need to remember. It doesn't matter what the inside is, but if the whole thing is raised to the power of 0, it will always be 1. But for number 41, it's a good way to remember that powers distribute to every single base. Base meaning bottom number. There are 2 bottom numbers here. This is not a bottom number. It's not a base. It's an exponent, right? So this 2 is going to go to both this 4 and to this y to the power of negative 2. So really what's happening here is I have a 4 to the power of 2 times y to the power of negative 2, also to the power of 2. So the first thing I'm looking for is 4 to the power of 2 should be a 16. So there should be a 16 somewhere in my answer. I'm seeing a 16, a 16. So A and B are eliminated. They don't have any 16. There's no way to turn the 16 into any other number or get rid of it unless I had like divided by 16 in the bottom. They could maybe somehow cross cancel. 16 is the only constant or coefficient that's in this problem. The next thing that I need to look at is this y base. So this y base has a power of negative 2 and another power. Whenever I have a power to a power, these 2 powers get multiplied. Negative times a positive is a negative, therefore, sorry, negative times a positive, yeah, is a negative. So I should have a negative 4. So this is going to turn into 16, again, from 4 squared to 16. 16 to the power of y, or 16 times y to the power of negative 4. And I mean, that's the answer, but the problem is usually don't want negative powers. Sometimes you should know how to get rid of negative powers, or sometimes negative powers are fine. It depends on the context. If this had been a multiple choice answer, I would have selected it. Those are not showing up here. Whenever I have a negative power, I can take whatever that base is and move the base to the bottom, and I can say this is now 16 over y to the power of, okay, it's not negative 4 anymore. It went to the bottom. It now absorbed that and turned into a positive 4, and that's going to be option C. For number 42, now I have division. So division means that I'm going to be subtracting powers. Let's do the easiest thing first, though. Anything to the power of 0 is 1. So this a to the power of 0 is just 1, and 1 times b to the negative 4 is just b to the negative 4, which is the same way of doing this. I really just kind of scratch that one out and ignore it. Oh, look, I have another power of 0. Go ahead and scratch that out. It's just gone. So now I made the problem easier. This is really technically b to the power of 1, right? One thing I'm noticing is in terms of coefficients, or these constants out front of these variables, there's only one coefficient, and it's in the bottom. It's attached to a power of positive 1. It's not attached to a power of negative 1. If it's attached to a power of positive 1, it's not going to move. If it's attached to any positive power, it's not going to move. Therefore, there should be a 4 in the bottom of my answer. This one doesn't have a 4 in the bottom. This one doesn't have a 4 in the bottom. This one doesn't have a 4 in the bottom. The only one that has a 4 in the bottom in the denominator is b. Therefore, the correct answer is b, just from that one fact alone. So where does this b to the power of 5 come from? Well, that's a great question. Whenever I have there's a bunch of ways you can think about this, right? So one of the ways you can think about this is whenever you have a negative power, you can take this whole entire base and move it to the bottom and make it a positive power. So you can say this is really, there's nothing left over on the top. There's a 4b to the 1 on the bottom, and now this b to the negative 4 is joining them, and it's going to be b to the power of positive 4, because it's now a positive whenever you take the reciprocal, right? When there's nothing left over, you have to have something at the top, so you leave a 1 behind. And then from here, you can say, these are being multiplied. Now you add their powers, and 1 plus 4 is 5. So that's one way to think about it. Another way to think about it is that you can do a subtraction problem. Typically speaking, my shortcut in my class is you look for the power that has more positive. So 1 is more positive than negative 4. So I'm going to do this number minus this number. I can say that this is going to be, we'll do a fraction here. So I'm going to have a 4b to the power of 1, and then this power of 1 is going to subtract this other number. Whenever you have numbers on, or you have terms on one side or the other of the fraction, you subtract. So this is going to be minus whatever this number is, so minus a negative 4. And then 1 minus a negative 4 is just adding, right? Double negative, add, 1 plus 4 is 5. So two different ways of seeing it. Again, whenever you have something missing on the top, you just leave a 1 as a placeholder. That's why we have the 1 up here. What about number 43? So the one thing that I'm noticing first is these coefficients. There's a 3, there's a 4. There's no way for me to cross cancel them. There's no distribution or anything happening here. So 3 and 4 should still be my final answer. So there's a 3 and a 4, still good. 3 and 4 are missing, not the answer. 3 and 4 are missing, not the right answer. 3 and 4 are missing, not the right answer. Just purely based on the coefficients, I know that the answer is going to be A. But you can check the other numbers as well. So if I have m to the power of 4 and m to the power of negative 4, if I subtract 4 minus this negative 4, 4 minus negative 4 turns into 4 plus 4, and 4 plus 4 is 8. Oh, look, we get an 8 there. What about this n? There is no power there, which means it's really a hidden power of 1. This comes from the fact that these are both n, and you can subtract powers. 4 minus this 3 up here is just 1, therefore you get n to the power of 1. All right. And, oh, yeah, that does conclude the video. Here are all the answers if you want to check them for yourself. That does conclude our Math 1 practice spring final. Thanks for watching.